MEI Statistics Minor, Bivariate Data 2, Correlation Coefficients, 2.6, Hypothesis Testing using Spearman's Rank Correlation Coefficient. So, a hypothesis test on Spearman's Rank Correlation Coefficient is very similar to a test on Pearson's Product Moment Correlation Coefficient. So when we perform a hypothesis test on Spearman's Rank Correlation Coefficient, it should be as follows. H0, no association between the first variable and the second variable. There is no row alternative. Because we don't define Spearman's Rank Correlation Coefficient of a population. Again, your alternative hypothesis will depend on what you're testing for. If you're testing for any association, then you will be performing a two-tailed test or two-sided test, and your alternative hypothesis will look like this. Some association between your first variable and your second variable. If you're testing for positive or negative association, that is a one-tailed test. And for positive association, your alternative hypothesis will look like this. Positive association between your first variable and your second variable. And naturally, for negative association, H1 will be negative association between your first variable and your second variable. Your test statistic will be the coefficient R sub S, as calculated in lecture 2.5. The critical values will be in a very similar table to Pearson's, but we just need to look for Spearman's Rank Correlation Coefficient. Remember, we need to focus on whether it's one tail or two tail, the significance level, and the sample size. Example 1. The owner of a cafe believes that the daily turnover decreases when the maximum temperature outside increases. Carry out a hypothesis test on Spearman's Rank Correlation Coefficient at the 1% level to investigate this. So, we're investigating whether one decreases when the other increases. That means that we've got a one-tailed test. And because one decreases when the other increases, we are looking for negative association. Our significance level is given to us in the question, and we should make a mental note that n is equal to 10. So our hypotheses should be as follows. H0, no association between turnover and maximum temperature. And H1, negative association between turnover and maximum temperature. Our test statistic, RS, is equal to minus 0.6485 to 4 decimal places, as we discovered in the previous video. For the critical value, we know we're doing a one-tailed test at the 1% level of significance, and we know that our value of n is 10. So our critical value is 0.7455. However, we're doing a negative test, so our critical value is going to be minus 0.7455. So our critical value goes about here. Since it's a one-tailed test, we're only going to have a single critical value, and as before, the insignificant region will include 0, because that is our null hypothesis. and our critical region will be anything outside this. Our test statistic is minus 0.6485, so it is within the insignificant region. So to finish off our test, the critical value is equal to minus 0.7455. The test statistic, minus 0.6485, is greater than this critical value. So it is not significant. So we do not reject H0. Alternatively, we could write that as accepting H0. So we finish our test by saying there is no significant evidence, making that very clear that we are still not certain at the 5% level to suggest that there is negative association between daily turnover and maximum outside temperature. In our final video, we will be looking at comparison of tests.